Here's a solution for problem number 7 from the final exam review for Engineering 1301. Okay, so we've talked about this in class, that here are a couple of ideal op-amps that show up in a circuit, and I've told you I don't want you to be afraid of op-amp circuits, because what we're doing in this class is just having you recognize, you put on your pattern recognizers and recognize a certain pattern that shows up with these circuits. All right, so I think you know the drill. What we're looking for is that these are amplifier circuits, and it's either going to be a non-inverting amplifier or an inverting amplifier. Okay, for inverting, we know that the output voltage of the amplifier is going to be minus RF, the feedback resistor, over R times the input. And for non-inverting, the output is going to be 1 plus RF over R times the input voltage. Okay, so non-inverting, it's called non-inverting because it's a positive gain. All right, you multiply by a positive number, typically that number is going to be bigger than 1. That's why they call it a gain. All right, or if it's inverting, you're going to multiply by a negative number bigger than 1. Okay, so when you multiply a waveform, all right, so if I started with this waveform and I multiply it by something negative, that would mean it flips it over. Okay, so it inverts it. All right, so that's why we call it an inverting op-amp. All right, so the question is, what do you see? All right, and so the answer is that if I take a look at just this first section, okay, just this part, this looks like an inverting op-amp. How do I know? Well, the input's applied to the minus terminal of the op-amp. When I say input, here's the source. You follow that, it goes to this resistor, okay, and is connected through that resistor to the input. All right, and it's on the minus terminal. The feedback resistor goes back and connects to the minus terminal. All right, so this is an inverting op-amp. All right, so that means we use this formula. All right, so I asked for both VA and V out, so you can get VA. VA, I take a look at the feedback resistor, that's 3K, and divide by the input side resistor, 1K, have a minus sign, and multiply by the input voltage. Okay, so this is coming out minus 0.6 volts. That's what VA is. Okay, so now the next stage, when you look at this, you have the feedback resistor. Okay, it goes from the output back to the input. It connects to the minus terminal. Okay, but the input from the previous stage is connected to the plus terminal of the op-amp. All right, so this one, this particular side, and these are connected in series. This highlighted in the red is a non-inverting op-amp. Okay, so we can identify, we can identify the feedback resistor. All right, so that'd be 20K, and the input side resistor is 10K. So, and the input voltage is minus 0.6 volts. So V out. All right, keep in mind these are just the formulas. All right, so let's take these and move them. Easier said than done. It's really frustrating. Okay, so move that out of the way. V out is going to be minus 0.6 because that's coming in. 1 plus RF. RF is 20K. divided by 10K. Okay, so that's 1 plus 2 is 3. So this is going to be minus 1.8 volts coming out for the output. Okay, op-amp problems, those should be easy on the final.